Okay, we said that the vertex was where we found that information. That vertex, in this case, is called our maximum because it was at the top of the graph. But you also sometimes have parabolas where it's going like this. If that was the case, it would be called the minimum. Now, there is a way to find the vertex without having to use the calculator or the graph and all that, which could come in handy, especially if it's not even numbers. The x-coordinate of the vertex can be found by using x equals negative b over 2a. That should remind you of something. It's part of the quadratic formula. It's not the part with the square root, but it's the rest of it. So let's try it and see if we get the same thing. If we use that on the function we just had, x equals, remember the b was 75, so that would be, let me write the formula down first, negative 75 over 2 times a, and a is negative 25. I get negative 75 over negative 50. So a negative divided by a negative is going to give me a positive, and 70 divided by 50 gives me 1.5. Then, if we wanted to find the y-coordinate that went with that x value, all we would have to do is plug in 1.5 into our function. Remember, our function was negative 25 times x squared plus 75 times x plus 450. And if we put that into the calculator, so let's go over here. That was negative 25 times 1.5 squared plus 75 times 1.5 plus 450. And we get that the y value that goes with 1.5 is 506.25. And indeed, that was exactly what we got with the calculator. Now, the other important features on the graph are intercepts, so let's talk through those a minute. An intercept occurs at the point of the intersection of a graph and one of the axes. So the x-intercept is where you cross the x-axis, and that's the value that makes our function equal 0, or our y's equal 0. The y-intercept is the value when x is 0. So what is the y-intercept of the graph of a of x? So if we look back at the graph, the y-intercept was right there. That was 450. So let's remember that as a point. The y-intercept is the point 0, 450. And what is the significance of that point in terms of the calendar problem? Well, let's remember what the x stood for and what the y stood for in the calendar problem. The x is that increase in price, and 450 is the amount earned. So this would mean that we earn $450 if the price is increased by 0. In other words, if we don't increase the price. So that is how much they would have made if they kept the price at $3. And remember, they said if they kept the price at $3, they were going to sell 150 calendars. So it makes sense that $3 a calendar, 150 calendars, would be $450. Now let's look at the x-intercepts of the problem. And there are 2 of them. If you look back at your graph, there was one x-intercept at negative 3. And the other one was at the point 6, 0. And what is the significance in this problem? Now, remember that this y values are how much we're earning. So on both of these, this means we would earn no money. And let's think about that. If this is how much we're increasing the price. So negative 3 means we decreased the price by $3. The calendars were already $3. If we decrease the price by $3, the calendars are free. And we make no money. Now what's the other option mean? The 6 is where the X is. So that means we would increase the price by $6. What happens if we do that? If you increase the price by $6, nobody's going to buy it. That would yield no profit. Now remember, one way to find the x-intercepts is to find the solutions of your equation when you set it equal to 0. In other words, when you let your f of x or your y be 0. So let's verify that we got the right x-intercepts and show that algebraically. So our equation was negative 25x squared plus 75x plus 450. And if we set that equal to 0, we would be able to find our roots or our x-intercepts. Now let's see. Let's divide both sides by negative 25 and make this a little bit easier to work with. If divide negative 25 by negative 25, I'll get a 1. So 1x squared would be x squared. 75 divided by negative 25 is 3. 450 divided by negative 25 is going to give me, use your calculator if you're not sure, 450 divided by negative 25 gives me negative 18 equals 0 divided by anything is 0. X squared plus 3x minus 18. Remember, we have several ways to solve this. You could use the quadratic formula, you could use completing the square, you could factor it. And I think I'm going to choose factoring. I'll do the hard part. X times x is the only way to get to x squared. Now remember, these two, when you don't have to worry about anything in front of x squared, are going to multiply to be negative 18 and add to be a positive 3. So that would be a positive 6 and a negative 3. Remember, when you're solving by factoring, you set each factor equal to 0 and solve. So the first one would give us x equals negative 6. X minus 3. Whoops, did I have them backwards? Or did I mess something up? I did mess something up. I hope you caught it. When I divided 75 by negative 25, this should have changed to a negative here. What would that change about my factors? Well, that would mean this one would have to be negative and this one would have to be positive. So x minus 6 equals 0 means one of the x-intercepts is x equals 6. Setting x plus 3 equal to 0 means one of the x-intercepts will be x equals negative 3. Now, remember, we had talked about that this graph is very, very, very symmetrical. So the next thing I want to look at is what would be the exact middle between those x-intercepts. If I found the average of those x-intercepts, average of 6 and negative 3, let's see what we get. The average of those would mean I'd take 6 plus negative 3 and divide by 2. That gives me a 3 divided by 2 which is 1.5. Guess what? That was that x coordinate of our vertex. It is also the symmetrical center. So let's look over here, back on my graph. That at that 1.5, excuse me. Oh, I didn't mean to sneeze right on the camera. Okay. At 1.5, I could draw a little imaginary line down the middle, and it splits the parabola right in half. That little imaginary line has actually got a special name. It's called the axis of symmetry. In other words, the left and the right side are identical. Now, the neat thing about it is it goes straight through the vertex, and it's halfway between our x-intercepts. It's actually at the line x equals 1.5. Remember, x equals means we have a vertical line. So the axis of symmetry is halfway between our x-intercepts. It also goes straight through our vertex. It is x equals 1.5. So there's two ways to find that. Now let's look through an example that's already on your worksheet. If we had a quadratic and we needed to find all those important features, let's talk through how we would find each one of them. So if we had 2x squared minus 9x plus 4, that means a is 2, b is negative 9, and c is 4. We can use that formula that we just talked about, negative b over 2a, to find the x-coordinate of the vertex. When you plug in negative b, and b was already negative 9, and then 2 times a, and a was 2. So negative and negative 9 is going to give me a 9. 2 times 2 is 4. So you get 9/4 for the x-coordinate. Now notice, they plug in 9/4 into f of x to find the y value that goes with that x-coordinate. And we're going to do one of these in just a second. And so you might want some scratch paper for that. Now, to find the y-intercept, we evaluate the function when x is 0. You let x be 0. So if you plug in 0 into the equation, you end up getting 4. So the y-intercept is at 4. The x-intercepts are found when y is 0. So you set your function equal to 0 and solve for x. And you can solve for it by factoring or by quadratic formula or whatever makes you happy. Now the axis of symmetry is the x-coordinate of our vertex. They are identical. It also could be found by finding the halfway point between our x-intercepts. Once you have all of those key points, graphing is so much easier. So I'm going to do, let's do one of these. Let's just do A to get the idea. Now, you notice over here that they show you a little tip, a math tip. If your A is positive, your parabola will always open up. If A is negative, your parabola will always open down. Actually, I said let's do A, but let's do C instead because there is something in front of it. So before we do anything else, let's talk through the examples. This one is x squared in front, so this one would open up. This one is a negative in front, so it would open down. This one is positive, so it would open up. Negative would open down. I'm going to do this extra example, A, to make sure we're on the right track. And I'm actually going to grab some graph paper So if you'd like to pause and grab graph paper, you can. Or you can just follow along, because it's very much like the example that was up there. So I decided I was going to do C, which is f of x equals 2x squared plus 8x plus 3. So remember all our parts. A is 2, B is 8, and C is 3. So to find the vertex, we start by finding the x-coordinate. The x-coordinate is found by the formula x equals negative b over 2a. B is 8, so that'll be negative 8, and we'd have 2 times 2. So that's negative 8 divided by 4, which is a negative 2. Now that's just the x-coordinate of the vertex. It is a point, and a point always has an x and a y. To find the y-coordinate, we plug in that x value into our function. So we need to evaluate f when x is 2. So you'd have 2 times negative 2 squared plus 8 times negative 2 plus 3. Negative 2 squared is 4, so 4 times 2 is 8. This would be a negative 16. So I would end up with, that'd be a negative 8 plus 3. I believe I get a negative 5. So my vertex is at negative 2, negative 5. Now the next thing they asked for was the y-intercept. Y-intercept is pretty easy to find when you're looking for it in an equation. We let x be 0. So we're evaluating the equation when x is 0. 2 times 0 squared plus 8 times 0 plus 3. Oh my goodness. Those go away and we're just left with 3. So the y-intercept is the point 0, 3. The x-intercept is found when y is 0. So let y be 0. Or in our case, f of x. We set our function equal to 0. And we would solve it. So let's see. I'm not sure if it factors or not. So one thing we can do is use the quadratic formula. You could also do completing the square if you like that. Negative b, so that'd be negative 8 plus or minus square root of b squared minus 4 times a times c all over 2a. So there I'd have 8 squared minus 4 times 2 times 3. That gives me 40 underneath over 4. We can make it a little bit prettier. Square root of 40, you've got 4 times 10, so that would be 2 root 10. But the point is, on this one, it is going to be decimals for our x-intercepts. And if we wanted to find the exact ones, we could find, well, the approximations, because that is exact. But I'm good with that. The last thing is the axis of symmetry. Now the axis of symmetry is super easy if you already know your vertex. The axis of symmetry goes straight through the x value, and it's a vertical line. So the axis of symmetry is just x equals negative 2. And then we could plot the points. You could also put it in your calculator to plot more points. But I wanted to go over how to find all of those main features. Now this one would be a graph that's opening up. So that vertex would be down here. That vertex would be what we considered a minimum value. Every other point on the graph is higher than that point. Okay. Now, looking back at that problem that we started with, the Picasso problem, here's our graph again. Suppose that Miss Picasso raises $450 in the calendar sale. By how much did she increase the price? Explain your answer graphically and algebraically. So the price increase, let's think about that, 450. If we look at it graphically, here's 450, and there are 2 points that have an output or an amount at 450. Graphically, we found that it's either 0 or 3. Because those are the points that have a y value of 450. Now, algebraically, those points will be found by taking 450 equals negative 25x squared plus 75x plus 450. I'm going to get everything to one side, so I'm going to subtract the 450. Oh, but that makes it interesting down here. I end up with nothing as my constant. I'm going to divide both sides by negative 25, and so I'll get 0 equals x squared. That's going to give me a minus 3x. Now this is interesting because I only have 2 terms. So I'm going to see if I have a greatest common factor. What do these 2 terms have in common? They both have an x. I can undistribute it. X times what gives me x squared? An x. X times what is negative 3x? Well, that would be a negative 3. It is now technically factored. This x is one factor, and x minus 3 is the other one. You literally set each factor equal to 0 and find the x value that makes that true. 0 is one of them, 3 is the other. Now remember what these mean. They mean that she increased the price by $0 or $3 would give her the same amount of money, $450. Suppose she wants to raise the money $600. Well, the maximum was $506, so $600 is greater than the maximum. And that would be talking about it graphically. Now, algebraically, how could we prove that she can't have $600? Well, you would take your equation, or your function, and set it equal to $600 as your amount that you want. And we would need to solve for x. So this is algebraically solving the equation. I'm going to subtract the 600. And that will give me negative 150 here. I'm going to divide both sides of the equation by negative 25 again and get x squared minus 3x. And then I'm just going to double check my work here. 450 minus 600 was negative 150. Divided by negative 25 gives me a 6. If I try to use that in the quadratic formula, negative b would be 3 plus or minus square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is 6, all over 2 times a. Notice what happens. 9 minus 24. We're going to get a negative number in that discriminant. So the solutions are complex. That doesn't exist on our graph. Now, we could do the same thing to prove that the x value that gives us 506.25 is found the same way. You would set your function equal to 506.25 and then solve it. So let's see how that would work. 506.25 equals negative 25x squared plus 75x plus 450. I'm going to subtract the negative, subtract 506.25. Now this time, I'm not so sure if I want to divide everything by negative 25. We can, but it gets a little ugly. To solve this one, I would just go straight into the quadratic formula. Negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. It is ugly numbers, but that is okay. Real-life problems tend to have ugly numbers. Now, I'm going to find out what's going to be in my discriminant so I can make sure it's nothing complex, and it shouldn't be. 75 squared minus 4 times negative 25 times negative 56.25. So notice, I'm just finding... Whoops, I messed up somewhere. I know what I did. I put a minus instead of a negative. That will give you an error. And I got 0. Oh, yeah. If you take the discriminant is 0, don't you end up with one solution? One real solution? One real rational solution? We do. It's negative 75 divided by negative 50, which is 3/2, or 1.5. So knowing that that discriminant is 0 means we only have one real solution. All right. Now, what price increase would yield $500 in the calendar sale? Explain how you determined your solution. Now, you could do this algebraically or graphically, because if you look at your graph, and remember we looked at the table as well, price increases would have been $1 or $3, or I'm sorry, $1 or $2 increase in price. Now we're going to review a little bit, thinking about those discriminants. If the discriminant is greater than 0, then you end up with two real solutions. You're going to have two actual x-intercepts. If b squared minus 4ac is 0, you have one real solution, or one answer. If that was from the original equation, you would actually have it touch only once, one x-intercept. If we have less than 0, then that would be those complex solutions, and it would never, ever, ever touch. So we already knew how to use the discriminant to find those things. The last part is looking at quadratic inequalities. Quadratic inequalities, very similar to linear inequalities. We would figure out what the graph would look like if it was just an equal sign. We would figure out where our x-intercepts are, where your y-intercept is, where your vertex is, all of those things. Now notice they put a dashed line. That's because this greater than symbol did not say or equal to. So a dashed line would be in place. Now, to figure out whether to shade here or outside, one way you can do it is to plug in a point. 0, 0 is a great point to plug in as long as it's not on the quadratic. So if I took 0, 0 and plugged it in, so watch what happened. They got 0 is greater than 6. That is a false statement. That means that 0, 0 was not part of the solutions. It's not part of that feasibility region. So you don't shade there, you shade above. And that's another way to think about it. Greater than would mean we're going to shade up over the quadratic. So let's look at one. Y is greater than or equal to x squared plus 4x minus 5. Now, one point that's really easy to find, and since they didn't ask for everything, I'm just going to do a quick sketch. Y-intercept. The y-intercept is found when x is 0. So let x equal 0. You're going to lose both of those x terms, so your y-intercept is going to be 0, negative 5. My x-intercepts are found when the y is 0, so you would set your function equal to 0 and solve. Let's see if this one factors, because that would make life super nice. X and x. Ooh, what about a positive 5 and a negative 1? That would work. So my x-intercepts are negative 5 and 1. So let's think about how this graph would look. Negative 5 for a y-intercept. 1, 2, 3, 4, 5. X is negative 5. 1, 2, 3, 4, 5. And x equals 1. So this graph is going to open up. It's positive. This is going to be a solid graph. And are we going to shade above it or below it? Well, greater than means probably above, but we can check it by plugging in 0, 0. Is 0 greater than or equal to 0 plus 0 minus 5? It is greater than negative 5, so we would have shaded up here.